Hello and welcome back to the Project Hercules Diaries. Now I've just been using around batteries. This is the battery off the big red Guzzi Lorenzo and it's 270 cold cranking amps, it says on the battery somewhere. There it says right there. And these are the wires that we were using in the previous video just to see whether or not we had any chance of starting the bike on the battery. And as you saw, even with a decompressor in one of the spark plug holes, the only way we would get a decent rotational speed is by taking both spark plugs out. So this morning, just for fun, I thought I would bust out the big guns and take the battery off the Volvo, which is nearly 800 cold cranking amps, just to see what would happen. I've tried it with the spark plugs in, I've tried it with one plug-in and a decompressor, and I've tried it with no plugs in, and while it does turn the engine with no decompressor, it doesn't turn it quick enough. It sort of just about manages to get the lump over top dead center and then flies around the other 3 strokes and then comes up to compression and slows right down. So it wouldn't be suitable to start the bike, and the dyno start does get a little bit on the warm side but not overly hot. So if I just give a quick demo of the type of rotational speed we get with nearly 800 cold cranking amps. So each chuff that you hear is the compression on the air coming out of the spark plug holes. So if you multiply that by 2, you get the RPM. We've timed it, it's about 300 RPM. So obviously this battery is too big to carry around on the bike. I don't want to have to take a trailer behind it just to tow the battery. That would be a little bit counterproductive, wouldn't it? So what I plan to do, you can get a lithium polymer battery that's just slightly smaller than this at twice the number of cold cranking amps, 540, and I think that with a homemade decompressor in the head of at least the same surface area of 2 spark plugs, preferably slightly higher, that would allow the engine to rotate about the same rotational speed, 300 RPM. Let it accumulate speed, and at the right moment in the cycle, drop the decompressor. The flywheels will carry it over top dead center because they're 50 kilograms, and that should give us the right rotational speed and energy to start the bike. So that's the plan. Now, fitting a decompressor into an existing head isn't as straightforward as you might think. It's been drawn up on the board by Mr. Bob, so I'm going to pop next door, see if he's in, and if he is in, we'll have a look at the drawing board. Stand by and I'll teleport myself there. Oof, here we go, back to the drawing board. Oh, there's me. Hello, nice to see you. So back to the drawing board, and you can see here where Bob's drawn up 2 things. So we've got a drawing looking down the top of the existing cylinder head. You can see where the 2 spark plug holes are and where we intend to fit our decompressor. So there would be 4 holes drilled into the cylinder head to allow the mixture to escape, and the central hole is effectively a valve guide. And then looking side on, this is the side profile of the head. You can see that the valve comes in at a slight angle. We wouldn't use an automotive valve, we just make our own, cut a seat at 45 degrees, and you can see how much metal is in there around to support the valve. You've got to remember that there is no hot gas escaping past here. This isn't a conventional valve like in a poppet valve engine. It's open when the engine hasn't fired. It snaps shut and then the engine does fire, and it remains shut all the time. So it's not quite the same as a standard valve. So it doesn't quite need to be the same resistance to hot exhaust gas, that type of thing. Now there is a problem, however, because we have over here the original Bristol Aircraft Company drawings of their cylinder head, and as it transpires, the cylinder head, looking at the side profile, isn't one piece. So the bottom piece of it is an interference press fit into the side piece. It's not particularly clear on this drawing. That means we can't come too close to this edge here where you can see the head is pressed onto, the bottom half of the head is pressed onto the sides. So that limits how close we can come to this wall here. So what we've been thinking is that actually it's just as easy to make a new cylinder head, which is over here. And if we make the new cylinder head with a flat bottom instead of a concave bottom, it makes it easier to fit the decompressor. The decompressor can be vertical, so we don't have to cut the seat at an angle into a sloped edge, and this isn't going to encroach on the plug leads and anything like that, and it makes it easier to activate the decompressor from the top. So looking from the top, we would put the decompressor in the center of the head, move the spark plugs to the side of the head, and then it just makes it easier all around one rotary table to make these 4 holes here. And if you look at the volume of decompressed, the surface area of these 4 holes compared to the surface area of the 2 spark plugs, you get much more gas escaping, so there will be no compression at all when the decompressor is open. So that should allow us to absolutely fly around that motor and then snap it shut quickly just at the right point in the cycle. The flywheel will take it over the top and away we go. So we have to make a cylinder head. Now, is it going to cause a problem losing a bit of compression? I don't think so, because we are at nearly 7-1, I think, or nearly 8-1, sorry, and losing this bit here, we've done the calculations, takes us to just around 7-1. It was never a high compression engine because it was supercharged. I have here a head. So this is a head from the original Bristol Hercules. You can see the bottom is slightly concave, and why that presents a challenge in fitting something in. And also you've got all these cooling fins to cut around, and it would be quite a challenge to fit something in here. And because this is a working serviceable head, there's always a danger of messing it up. Making it from fresh aluminium will not be a difficult job. We can put it in the forge, or we can turn this round. It shouldn't take too long, and then drill the stud pattern in to fit the engine. The last thing I've got behind me is a cylinder head from a Centaurus, which is a later version of the aircraft engine, with an extra 2 cylinders, and you can see that's actually got a flat bottom of the head. Unfortunately, it's a different stud pattern, so it doesn't fit on the barrel of a Hercules. Otherwise we could have potentially used this head, benefited from a little better cooling, but I'm not so keen on the top of that. I like the simplicity of this head. It just makes people wonder what it's about. We probably wouldn't bother with cooling fins. We'd make it with aluminium. It means it's lighter because this is a cast item, and it's quite a weight in itself. So there you go, that's the plan. It does mean it takes a little bit longer because we've got to make a head, but that is okay, because it's all about making things as well as using things, and it's good to draw everything out. So we haven't cut any metal, we haven't spoilt the head, and we always knew when we started the project that we would need some kind of decompressor, so we just carry on as we were. Right, that's it for today's ramblings. As usual, thank you for watching. More updates will follow. See you later.